Dust storms are a scourge of modern life in much of the world.
Three, two, one. Engines start and lift off.
One of the best ways to study dust storms is by satellites orbiting the Earth.
People didn't understand the intensity and how far these storms could move until we had satellite imagery.
NASA has over 20 Earth-observing satellites that are monitoring constantly different components of the energy and water and carbon cycles. Using satellites, we're able to get a global picture of the land surface and different components of the land surface. For example, you can monitor the type and amount of vegetation. In addition, you can also tell how wet the soil is by using microwaves. So if you know how wet the surface is, then you have a better idea of the intensity and duration and locations of potential dust storms.
NASA's Goddard Space Center is the largest organization in the world monitoring the Earth, the solar system, and the universe. 10,000 people work here, and several hundred scientists specialize in looking at the Earth. With the information satellites gather from land, sea, and air, scientists build computer models that help them simulate past and future conditions. Dr. Peter Kalarko is one of the team studying particles in the atmosphere.
So this is an animation from a global Earth system model that we run here at NASA. What we're simulating in this are the distributions of what we call aerosols, or particles in the atmosphere. And the different colors represent different kinds of these particles, and they come from all kinds of different sources. So the blue colors are from sea spray that's blown up by the winds at the surface of the sea. The greener colors come from smoke sources, and so there we have individual fires that are going off in the model and emitting smoke into the atmosphere, and it's transported over long distances. The whiter colors correspond to what we would call anthropogenic pollutants, so things that come from power plants or car emissions. And so you can see places, especially in China or on the east coast of the United States or even in Europe, where a lot of these pollutants are emitted and transported. And then finally, the redder colors that we have correspond to dust storms. And so in that case, what we're looking at is the effect of the surface winds blowing across a region that has a lot of fine particles that can be blown up into the air and blown by the winds over very long distances.
Using models like this helps scientists understand what's happening in the Earth's atmosphere. Other projects concentrate on collecting actual data about atmospheric particles. Dr. Robert Levy has been working on a long-term global aerosol record.
So this is the time series from the MODIS Terra satellite. We are trying to create global observations of aerosol. These are not models. These are based on camera-like images. How it works is satellites measure light reflected from the Earth. And you can see that there's places on the globe where you see lots of aerosol, which is a bright orange color. And you can see the hot spots around the globe. You see the dust in Africa, biomass burning in the Amazon. What we don't have from the satellite is exactly what it's made out of. You can get a sense of what kind it is, if it's dust, smoke, pollution. One place that you do see, at least in the 15-year record we have, is there seems to be an increase in the Middle East, along the Arabian Peninsula and in that region. And it seems to be a significant increase.
NASA studies back up what people on the ground can see for themselves.
Oh, look at that! Look at that! Look at this, man!
These satellite studies are now being put to practical use.
Look at that!
NASA shares its data with other research groups who are developing a global sand and dust storm early warning system. This former church in the Spanish city of Barcelona is now a world center for science. The interior is taken up by the massive Mare Nostrum 3 supercomputer, used by research scientists across the world. One project is to predict dust storms, in this case for Europe, the Middle East, and North Africa. Other centres in China, Japan, and Korea cover the Asia region, and the aim ultimately is to alert people when a dust storm is expected.
If we have a dust storm generated in a place like Syria and Iraq, it is very different from a dust storm which is generated from a place like Oman or UAE. Because in places like Iraq and Syria, we have had conflicts for years, so we have toxic elements which could be attached to the surface.
Dust.
For people living in dust storm areas, new technology could help. Nowadays, it's possible to check the dust forecasts online. These forecasts from the Barcelona website are part of the global early warning system. They're updated daily.
It provides a map with details of dust concentration in the Middle East and North Africa. If we zoom in around Syria and southern part of Iran, we see a high concentration of dust. The yellow color shows higher concentration. The dark brown is very high concentration of dust, which is well beyond WHO limits. So you will see what happens every hour in next 72 hours.
The forecasts are becoming ever more accurate.